Yo, yo, yo. What's up, what's up? Welcome back. Today we're working on my keyboard overlay that we're writing so that stream can see what keys I press when I press buttons, so that, like, I don't know. Part of, like, the fun of, I think, watching somebody else work is sometimes you, like, pick up habits from other people that are, like, kind of useful. And when I see people doing stuff in real life, I can, like, ask, like, hey, how'd you do that? Where when you're watching on stream, like, you might not want to interrupt, or you might not want, like, you might be watching, like, the VOD and not have that ability. So it's kind of fun to, like, show on screen the buttons that are being pressed, and then, like, if I do something like, oh, I'm gonna, like, delete this and put it over here, like, what I pressed to do that is, like, visible on screen if somebody wants to, like, was like, whoa, what's that? Also, it looks kind of fun, you know, whatever. So what we're looking at today is layout handling. So on my machine, if I go into, like, my, like, keyboard settings somewhere, I've done this thing where I've, like, swapped my control and caps lock keys. So it's kind of annoying. Like, I have support for, like, showing key combos. But sorry, let me just undo everything I just did here. There we go. For me, when I press caps lock, it should show control, but instead it shows caps lock, and so, like, these, like, combos aren't really being represented correctly. And the mechanism that we're using for reading keys doesn't really, like, have any knowledge of these mappings. And so I was doing, like, a little bit of, like, reading and, like, code perusing yesterday. And I think it's, like, kind of interesting enough to figure out how to get that stuff into our program that it's worth doing a stream on. So what have I learned up until now? At this point, my understanding is, let's see, we're reading keys from Linux. So we'll say that, like, we'll draw a line down here, and we'll say this is, like, the operating system, Linux. And he has this, like, handle to keyboard inputs, this, like, dev event or input, essentially. We're kind of, like, missing some stuff here, but we're reading this file from Linux that, like, tells us what keys are pressed. My understanding is when we open a program on Wayland specifically, there's two like, display protocols that you use on Linux. One is Sorg, one is Wayland. But let's say, like, my desktop environment, like, let's say, like, who draws this window? In my scenario is called kwin. So kwin is sitting over here. And inside him, he's running, like, a Wayland server inside him. And this guy is essentially, like, reading from here, I think. Well, let's just prefix everything with, I don't actually know what the fuck is going on. I'm just kind of, like, showing my mental model. And there are parts in here that could be wrong. But my understanding is that, like, kwin's essentially reading dev input and forwarding things to Wayland clients. So what happens when I open a window is I start up my application over here. This is me, and I'm, like, little smiley face. This is my app. And I'm going to have, like, a Wayland client here, WL. And so these guys kind of, like, talk to each other. And so, like, my application says, hey, I'm a Wayland client. Could you, like, give me a window that I can draw stuff in? And he'll be like, oh, sure, why not? And in order to get things like keyboard input, we kind of get them over this Wayland channel, I think. So I think what's going to happen is when I go into this, like, settings dialog and I say swap caps lock and control, my understanding at this point is that over this Wayland pipe, we're going to say, like, here's a xkbx keyboard, I think is what this stands for, xkb, like, file, and this is going to show you, like, the mappings of things from one to another. And then on this guy, he's supposed to use this, like, libxkbcommon to, like, read that file and look up the mappings. And then when I type into here, he says, like, here's the key that was pressed, and you convert it into the proper letter, like, do the conversions using this mapping. On X11, it's a little different. This is like Wayland. On X, you kind of have like a similar thing, but instead of Wayland, it's kind of more like, I think it's kind of more like this. So this Wayland channel won't exist anymore, and I think it's more like Kwin is like a child of Zorg, and I think that Zorg is kind of the guy who's doing all of this stuff. And so he's got like his keyboard mapping directly. And instead of doing this, I think that I can just ask like Zorg directly. And this is important because basically from X, like you can kind of just talk to whoever you like. How do I say this? There's like no like real permissions model, I think. And so like he could just kind of from anywhere say, hey, I'd like the keyboard mapping, what is it? And Zorg will tell him. Where in here, you kind of have to like go through this like specific Wayland channel, and here it's just like a free C function. And now, okay, so why is this important? So my application, this window is drawn by this library called eGUI. And eGUI calls into this library called winit, which stands for window init, I assume. And so this guy, he says like, well, am I running on Windows? Am I running on Linux? Am I running on Xorg? Am I running on Wayland? Like, what's going on? And he, under the hood, has like a Wayland client. And he also has this like XKB thing, I think. This is kind of like what I gathered from like browsing the code yesterday. And then he handles like talking to like the Wayland server. So this is like talking to Kwin. And so the problem here is that like if I want the mappings for like keys to letters and stuff, I need to like talk to Wayland. But this is like deep in the stack. And so if I'm over here, this is me, smiley face. I basically like can't get this information. Well, you know, everything's open source and like you could theoretically get it, but I was like looking, it doesn't seem trivial because like this guy's essentially running like an event loop inside and passing events up. And if I were to like inject myself in there, it would be like pretty intrusive. And so what I think I want to do is I think that I want to kind of make a connection like this where I have like a reference to XKB myself as well. And I think that I'm just going to like try to inject my like mapping over here. And so I think what we could do is there's this like utility to read the mapping. But that utility seems to only work really in X11 land because it's like easier to pipe that info around. And I think that what we can do is, I think that what I'm going to try is I'm going to try to like open up a X application to dump the mapping. And then once I have that mapping, reload it in my app and use it to take events from dev input directly instead of going through like Wayland stuff because I want app inputs from all applications, not just the one that I'm where my window is. And I think that will let me kind of like load the same mappings and do the conversions that I need to do, I think. So plan of action is I guess I'll prefix everything right now with question marks because I don't know when we're going to get to each spot. But the plan of action is something like figure out how to use libxkbcommon. Try to load mappings. Then integrate into application and probably like integrate mapping dump into app and then integrate usage of mapping into app. I think that's kind of approximately the plan. I think so. Yeah, so let's start here. So we're at like maybe like 9 minutes and 45 seconds of the stream. And we're trying to figure out how to use libxkbcommon. Okay, so let's just start by looking up libxkbcommon. And what I saw yesterday was in their repo, they have this like doc folder and they have this like quick guide section. And we can look at him to figure out like, well, what am I supposed to do to use XKB at all? And we'll start by like pretending we're an X11 client. Xorg, X11, all of these things are like kind of like intertwined in my head. I don't know which is which. And then try to like load the key map that we have. Try to prove that when we press the caps lock key, it comes up as control, and then we can kind of like move on from there. So before anything, we need a library context. So let's just like pull open like a little test C file and just start doing what they say to do. We need to kind of wrap this in like a main function. So kind of do this, and this guy's gonna say when he fails, he's gonna include stdio. So we have prints, and we're gonna say print f failed to create context. Cool. And then we're gonna return 1. I wonder why he doesn't like this. So xkb context new, he's struggling to import the header, so let's try making this guy. So gcc-o test of, I guess I can, hold on, let me make sure I don't have like a test file. gcc-o test.c. Okay, and he's saying, in function main, undefined reference to xkb context new, so I think I need to link xkbcommon. Okay, and so that builds, and if I run it, we return 0, which kind of indicates that it's working. So let's just keep moving. We're gonna ignore these errors from my language server for now because it doesn't know about the compile flags I'm using, and I don't really want to figure that out right now. Okay, so next we need to create a key map, and so you can either like, here's like the Wayland version, and here's the X11 version. Here we go. This is what we're looking for. So what is going on here? We don't have this XKB connection. Okay, here's what we're gonna do instead. We're gonna just ignore, we're gonna pretend we're in the simplest case, actually. I've changed my mind. We're gonna start simple and get more clever as we go. So I think that one of these, if we're an evdev client, we have nothing to go by. So we'll just start by trying to use, like, we don't have a mapping first. Let's just try to use XKB at all with no mapping, and we'll figure out how to load the mapping later. So I think I can just chuck a null in here, because we're not actually going to make any manual mappings, I think. We'll kind of see where that gets us. Key map should be a type XKB key map. So we'll throw this guy in here. And we will try to see what happens. Do we get an error here? So if this fails, we'll say failed to create key map. And we'll return 1, and otherwise return 0. So let's kind of yoink this guy out. And it looks like he's compiling okay. So that's pretty cool. Then they say that we need to create a XKB state, which remembers things like keyboard modifiers and like active LEDs and stuff. So sure, fuck it. We'll just yoink this guy. So he makes a key map, and if he doesn't have a state, we printf failed to create state. And return 1, otherwise return 0. Let's kind of put these like build and run into one step. And now they're saying like, hey, you can like create a symbol by passing in a specific key code, and probably that's going to start being something useful. Then probably we can like print it out or something. So when I was looking at this yesterday, I was looking at how do they like map evdev key codes to our thing. And if here they have like some samples, and they have this like evdev thing. And when they read from the evdev device, they do this like mapping of key codes, like, how do I say this? Evdev key codes to XKB key codes by doing like this thing here where they just say, our key code which is like the key code that we pass to our XKB thing, he is going to just be offset by 8. And I'm like, okay, sure, whatever. So if we include Linux, I think it's input event codes.h. Let me just double check that. I think that's what it's called. Yep. We can then just convert our evdev key codes to these guys, and hopefully we get like a symbol out. So we'll say our key code, we're just going to say, what happens if we type like key A plus 8? Because 8 is the evdev offset. And maybe we'll just like make that as constant. We'll say const evdev offset, what is it, int equals 8. And here we'll just add in evdev offset. And then what do we do with that key sim? We can get its name. We can get UTF-8. Let me look up like the APIs here. So libxkbcommon API docs. I actually want to see. I want to see what we can do with this thing. XKB state is probably what I'm looking for, and they're saying like key get UTF-8 is probably want to get the UTF-8 string obtained from pressing a particular key in a particular keyboard state. Okay, so we'll make like a little buffer of like size 64 or something. I don't know. Fuck it. We'll say we're going to pass in a key code and a buffer. So let's yoink this guy. And we'll say if this fails, I think that the return value is 0 if nothing. So say if this fails, we're going to, and what do we have to pass in here? We have to pass in the state, the key code, which is key A plus evdev offset, the buffer, so that's buff, and the size, which is size of buff. Here we'll say printf failed to convert key code and return 1. Otherwise, we can like log it out. So here we can just say, here, I'm going to say time to print this guy. So we're going to say, this is what we got. And X will say, retrieved code is equal to this. Okay. So that's a good sign. And I will note that I kind of cheated, and this is like what I've got this far yesterday. I didn't go any farther than this when I was doing some tests yesterday, but I did get to this point. So that's how we kind of like ripped through this so quick. But yeah, it looks like we're seeing a key code A. And I also noticed yesterday that if I start like injecting shift codes, so I can say like, there's some API in here to update key. Yeah. So here, with like, say I wanted to like press the shift button and then see what we get back out, I could say xkb state update key, and we pass in the state, and let's say we can press key shift plus the evdev offset, of course. So we say state key direction, which I think is just xkb key down. So if I do this, we should see uppercase A, if I remember correctly. Yeah, so now we see an uppercase A, where if we comment this line out, we get a lowercase a. So that's like a good sign that we can get something useful out of here. And now let's see what happens if I do key caps lock. Because this is where I'm struggling, and he's saying failed to convert key code. So maybe there's not a valid UTF-8 string for caps lock. Maybe. So let's try maybe just getting a key sim, and we'll see if that gives me something else. So get one sim is what we're looking for. Get one sim. XKB state key get XKB state key get one sim. He returns a key sim t, and we don't need to pass in this buffer. And I guess let's start with key A just to see what that looks like, and then we can kind of figure it out from there. So here we'll say key sim is equal to this. And let's see if we can like do anything with this guy. So a number used to represent symbols generated from a key on a keyboard. So can we like convert a key sim to something like printable? Key map creation, keyboard state, key sims. So we can say get name. Where get name and UTF-8 are different, I think. So let's kind of just try looking at that. So we can say if we fail to convert this, we return 1 and we printf failed to get key name. We pass in our key sim, our buff, and our size of buff. But I think we lost our buffer, so we'll just quickly do a car buff 64 real quick. And then we'll print out the buff. Okay, I think that's good. Okay, so here, if we pass in an A, we get the A printed, right? We see retrieve code A. And let's try the caps lock again and see if we get anything useful there. There we go. So we retrieved a code caps lock. Cool. So now what we want to prove is we want to prove that we can load the mappings that I've like set up system-wide and see if those give us anything interesting. So let's start working on that. So what I saw yesterday was that there's this program where let me see if I can find it in here. xkbcommon is what I'm looking for. And here I'm supposed to be able to say xkbcommon, and I punch in my x11 display and I as an input, and my output I can say like test.xkb or something. I don't know what like the correct file extension here is. Let me quickly download that application. Give it a sec. Okay, so if I run this, it gives me a warning, but if I look at what this actually outputs, and I try to look for caps in here, I think somewhere in here, I did see, yeah, this looks a lot like what I'm looking for, right? It's saying key caps is Control L, which means that like this file should have the mappings that I'm looking for inside it. And let's see if we can like figure out how to like load these mappings from the file. So in like the Wayland version of this guy, Wayland will, if I read like the winit code correctly, the like window initialization library code that I was looking at, it looks like Wayland sends us a file descriptor to look at that I assume has this mapping in it. I don't actually know. And so what I'm kind of hoping is if I just read this file into a buffer and then call the like Wayland version of this like initialization of the key map, then hopefully I'll get what I want. But I don't actually know. So let's kind of try to do that. So I guess that kind of goes in here, right? And here I need to make my key map string. And I guess what I want to do is I want to like read the file into this string. So what's the file name? We've called it test.xkb. So we need to like let file descriptor, nope, not let, int file descriptor is open. I guess we want file star fd f is equal to fopen. And we want test.xkb with read, I think. And then we're gonna want to like read that file. So man, fread, fopen, how do we do this again? It's been a minute. So we call path and mode, and then we read it with fread. So I guess we're gonna like malloc a pointer for this string, and I don't know, we just need to make it like pretty fucking big. So how big is this file? 52 bytes? 52 kilobytes. Okay, that makes more sense. So let's just we'll allocate like 60 kilobytes here, just so that it fits. And then we'll try to like f-read this guy. So we'll say size t read bytes is equal to f-read key map. We read into the key map string with a maximum size of 60 times 1024. One thing of, I guess, 60 times 1024 things of size 1, right? Characters, essentially. And we read from f file. And I guess here we need to do some checking. So we'll say, what if f is equal to null, printf failed to open key mapping, and return 1. And here, if read bytes is equal to 0, we have a problem. Printf failed to read key mapping to string, return 1. And then I guess the rest of this should line up. So let's cargo, oopsies, GCC this guy. And so he's claiming that he doesn't have malloc. So let's just include stdlib. And then he's saying that he failed to read the mapping to string. Failed to read mapping to string. So why is fread failing here? Return value on success, fread returns the number of items read or written. This number equals the size of bytes transfer when size is 1. Oops. Maybe I have this backwards. Maybe it should be this way. Ah! Cool. Okay, so now everything else kind of just kept working. And we're seeing that like the key code that we retrieved is indeed Control L, even though we passed in caps lock as our press key. So that's really sick. We have like some form of proof now that this will work, right? We have a way to get the mappings, bypassing the Wayland pipe, and we have loaded them, and we've proven to ourselves that if we press the key that we want to press, that we're getting out what we want to get. So I think that's kind of like the initial prototype check kind of thing done. And now it's time to like actually just start using it. So I think probably what I want to start with is I want to start like integrating this like xkbcommon library into my application. I'll just like start by providing the mapping on the command line, I think. And then we can add in this like hack dumping thing after. So we're at around like 2830. Integrate usage of mapping into the app. Let's do that. So I guess we can just kind of open up our main and kind of see what that looks like. So the first thing that we're going to need to do is we're going to have to like take in the mapping as like part of our arguments. So we'll say that like the mapping path. Well, first actually let's check our git status. Make sure we're in like a semi-clean state. And let's make a new branch because I do want to track this separately. Like we're not like in a clean state right now, so I kind of want to keep. I'm gonna try to like commit this stuff cleanly and then like rebase it onto the cleaned up version of the stuff before or after. So we'll say xkb is gonna be our branch name, and we're in a clean state, except for cargo lock. So we'll just kind of add. You say cargo lock. Okay. So now let's kind of like pass in the XKB mapping as a, maybe we'll say that it's mandatory for now, I guess. And we'll throw this into our argument parser. So we'll say the argument is xkb mapping, and if we see the flag xkb mapping, we should be putting the next argument as its value. So we'll say xkb mapping is equal to that guy. And down here, we have to convert him from like an option into like a full thing, because at this point we'll be like, hey, we've parsed all our arguments, and at this point we should have the xkb input. And so I think, what did I call this? I said xkb input missing. Working around the security features of Wayland with xkb. Well, technically I'm not breaking any security things because I had to add my user to the group that's allowed to read these files. Right? Like, most normal users and normal apps shouldn't be able to do this, but because I'm in the input group, I'm allowed. And maybe, like, I've seen other people kind of spawn a second process with root permissions to read it, but I think that there's no, like, we're not, like, breaking any security. We're just we're just doing our own thing, I guess. Okay. So now we have our xkb mapping path, and someone should load him. So I guess if I run this, we should this should fail to run because we didn't pass in the xkb mapping path. So let's just double check that. And yeah, he is saying argument parse xkb input missing. I forgot to update the help as usual. So we'll just throw this guy in here as, what did I say the argument was? xkb mapping. We'll say path to read xkb mapping from. I guess theoretically this could be optional, but I don't care because I'm the only consumer of this application right now. So now when I run, I should get like a nice help message that tells me, hey, you should fucking type that number, that other thing. xkb input missing, and then he's saying here it goes, so I can just throw in xkb mapping is test.xkb. Sick. Okay, so now that application is running again. And actually, if two of these are running at once, do they both get all the keyboard events? Nice, they do. They do. Okay, so now I probably should make some sort of like xkb wrapper. So I guess what we're gonna have is we're gonna have a like we're gonna have bindings to the library, and we're gonna auto generate those, and then we're also gonna have to like wrap the library in like our own class. So I'm gonna make a directory in source called xkbcommon. And in source xkbcommon, I'm going to make a mod.rs, which is like going to be where I store the Rust safe wrapper. And then I'm going to say source xkbcommon bindings.rs, and this is where I'm going to store like the generated C bindings. And so what we're going to end up doing is we're going to end up storing these like pointers to xkb things, and we're going to like implement our like drop or like wrappers for like smart pointers, and then we're going to like make a structure that wraps these things into like Rust APIs. Okay, so with these bindings, these are going to be very similar to the input bindings that we already generate for fdev, but instead of input bindings, we'll call this like xkb bindings. Seems reasonable. And then in our build script, we have this thing what we do right now where we generate a bindings file for input. And I guess we can just do the same thing. I guess we should call this generate input bindings, because naming functions is going to make things easier in the future. And here we're going to say generate xkb bindings. And we're going to do the same thing that we did before. We're basically like looking for a specific header. Where here it's going to be xkbcommon xkbcommon.h, and this is going to go to xkb bindings, I think is what I called it. Yeah. And then in here, we just make a main function, and we call generate input bindings and generate xkb bindings. Easy. Easy peasy. You could argue that these guys are using some common code, and then as I say that, it's like, fuck, fine, I will factor that out. So we'll call this generate bindings, and the only thing that we're going to take in is a input file content, which is going to be a string, and that's going to go here, input file content, and he's going to say output path is also going to be a string, like this, and this is going to go here. We'll call it output file name, I guess. And here we just have to pass this guy in here. So we'll say output name. And then each of these guys basically says, instead of doing this, I'm going to call generate bindings with this and input bindings rs. Fine. Fine. And we do the same thing here for xkb. So say xkbcommon, xkbcommon.h, delete this, and this is xkb bindings. Fine. We will write slightly better code. And if I build this, does it still build? What's he bitching about? He's saying that I can't find xkbcommon, xkbcommon.h. So how do I resolve that? Let's make sure that I got the header name correctly. So in our test file, it was xkbcommon. But let's maybe copy paste this just to be sure. Oopsies, that's not what I'm looking for. I'm trying to cargo build. And there's probably just some sort of like bullshit include argument stuff going on. So what's the usual way you handle this is you say, hey, package config, I have this library, xkbcommon, and I would like you to print out some, like, what arguments should I pass to my compiler to throw those in. And then there's like linker flags as well. What is the thing? It's like libs. And that will give me some like linker flags to pass to my program. And so what I can do here is I can say, what's it called? There's a argument, there's a like, this guy, bind gen extra clang args. So this is like, when I'm generating my bindings, here are some extra things to pass to clang. And so I think what I can do is I can say export bind gen extra clang args is equal to the existing clang args, followed by package config, the output of this guy, I think. So let's see. So now he's got an include path for libxkbcommon. And now if I cargo build, I think that this will succeed. Cool, it does. So I have to think about like whether or not I want to integrate this into the build script or into like my Nix environment. It probably makes sense for me to integrate into the build script and pass the flags directly, because I think that like somebody could have this guy installed in like a totally non-standard location and package config would pick that up. So let's kind of pull that guy in. So I think there's like, somebody's already wrapped package config for us already. Wow, dude, that's a lot of users. That's 118 million downloads, is crazy. But we can pull this guy in, and basically he's allows us to do the same thing that we were going to do there. Like what we just ran on the command line to like get the arguments, we can like run that here, and this guy will like let us do things like I think he allows us to like export to the rest of the build, like the linker flags as well, which is gonna be relevant later. Package config rust build rs linker flags. I'm sure somebody has like an example of this. Documentation. Is there like a book? Does this probe library print shit for me? Because what this should end up doing, simple shortcut for using all default options for finding a library. Okay. What you should have to do is there's a way to like say like print cargo like link flags, and then you like pass in some stuff here, and then cargo will automatically add those linker flags to Rust later, I think. And I don't know if I have to do that manually if I use package config here. This package config library, so I'm trying to figure that out. Which is why I'm Googling this like string of shit. Build scripts, the cargo book, rerun and file change, build script examples, linking to system library. Ah, here we go. This is exactly what I want. See, they call in package config, and so they probe library, and they don't do anything. It automatically handles that shit for us. Pretty cool. Yeah. Pretty straightforward. So, cool. Yeah, that looks good. So we'll just do this. Where we pull in package config 0.3.27 in cargo toml. Say package config. Is it underscore? I can never remember if I'm supposed to put underscores or hyphens. One of them is not allowed. This is a hyphen. And what did I say the version was? 0.3.27. In our build script, we will say package config probe xkbcommon. Yo, what's up? Was it xkbcommon? Package config. What did I type here? xkbcommon. Cool. And expect, we'll say failed to find xkbcommon. This is probe library. And I'll say let libraries equal this. And we need to pass the include paths into this guy. So we'll say xkb cflags, I guess. And do they have like the cflags automatically here, or do I have to pull them out manually? ld args include paths. Xkb includes, I guess we'll call it. It's weird that I don't have like, I kind of want just the string. But it does kind of seem like they don't have a just give me the C flags, which is kind of like a downgrade from just calling it manually, but whatever. Whatever, we'll just pass in the includes as a... This is a what? Reference to a slice of path buff, I guess. So we need to use std path buff. Wonderful. And then here we pass in library.c, what was it? Include paths with an ampersand. And in here we'll just add support for like C flags. Extra includes, we'll call it. Like this. And include, is there like an include paths on the bindgen thing? Bindgen. He's going to have to look for these. So builder, include, detect include paths. Interesting. Do I just have to like pass in the extra arguments manually? C flags, C flag. What am I looking for? I would think that this object would let me add extra includes manually, but maybe not. Clang arg. So I guess I just pass in extra arguments. So I guess for each of these guys, I'm gonna throw in, I guess we'll say extra includes. We'll say let cflags is equal to extra includes dot into iter dot map value, and he's gonna turn into something like dash I and value dot display. And then we'll hook these cflags onto clang args cflags. Okay. And then here, this guy has no arguments, so we'll just kind of throw this on here, and this guy will pass in the xkb includes. Okay. Okay. Are you going to support all kinds of locales or just USEN? I'm kind of hoping I just get this for free if I use xkb. That's what I'm hoping, but I'm not really sure. I'm just kind of like, type in and we'll see what happens at the end of it. I recommend a xkbcommon keyboard. Well, I programmed a xkbcommon keyboard once. I can't say I know how to write on it. What the hell is that? I wish I could copy paste better here. Okay. You've piqued my curiosity. Acrylic layout Russian. Oh, interesting. Yeah, so what do you guys do in other languages when programming? Because I assume all of the keywords are still like fixed to English. Does it just mean that like you would just memorize QWERTY layout and then switch to QWERTY when programming or something? I assume that's what you would do, but I don't actually know. And then did you just have to like learn English enough to like write variable names? I've never really thought about this before. Okay, does my build work? It should still work, and pretty sick. You're Dutch to use QWERTY, that makes sense. So let's check if my bindgen args, they should not have those extra flags anymore, which they don't. We don't have the xkbcommon, but it looks like the package config stuff did work correctly, which is pretty cool. Okay. So now if I go into xkb here, and I guess we're going to mod xkb bindings, I think is what we called them, or bindings. That should still build. Also Dutch, but use Azerty, which I guess is also like still Latin based, right? So you're probably good to just like it's just normal to me programming, I would guess. Yeah, interesting. Cool. Here we go. Okay, so what am I going to do here? I'm going to have like some sort of like XKB wrapper. And we don't know what's going to go inside him yet. But we have like this test program that we wrote, and we can kind of use this as like a sample for what we're going to do. So I guess we know that we're going to have a function new that creates this guy. And we also know that he, at this point in our lives, is going to take in the XKB mapping path. And so I guess we'll call this a path. And so we're going to have to use std path. This is unimplemented. And just let's make sure this still builds. Cool. And then somewhere in our main function, we're presumably going to like create this thing. So let's just kind of try making him at the beginning of main, and we'll figure out what we want to do after that. So say let xkb is equal to, I guess we need mod xkb here. So we'll say, and we need to, I guess, use xkbcommon xkb. And this is going to be equal to xkb new args dot xkb mapping. Okay. Does that still build? He doesn't like this as a private struct, so we'll just huck a pub on that guy. And new is also private, so we'll just huck a pub on that guy too. So that compiles, great. And now I guess we can also assume that this is gonna fail, right? Because there's a lot of things in our test program here that like could have gone wrong, right? We have all of these like checks that are failing. So let's say that this guy is going to be resolved, and we'll say like xkb creation error is what he could return a failure. And in here we will, I guess, say this is going to be like an enum of some sort. And this is going to be a result xkb creation error. Cool. This has to be public as well. Makes sense. And what's next? So here we're just start running through this C code. So we're gonna want to store the context, who is a mute pointer to a bindings xkb context. Maybe it makes sense for me to just like star import all of the bindings module. Maybe it's fine to prefix them every time. Sure, I'll leave it like this. And here we're gonna say let context is equal to bindings xkb context new xkb context no flags. Cool. I guess we're going to want to like free this stuff when we finish as well. So we'll impl drop for xkb. And you could argue that I should implement like smart pointers around this. Like each of these guys should maybe be handled individually. And I guess that makes sense because then in this case, when I like create like 4 pointers and I fail and I return, they auto drop. So let's do it that way. So we'll maybe say we have a struct, and he's going to be like a generic struct of some form, and he's going to be like xkb pointer, and inside him he's going to have inner is mute t, and I guess we're also going to have to like store what we want to do on drop. So I think that maybe you can do something like in C++ with unique pointers, the like type of the function is enough to deduce what you're going to do on drop. I don't know if that works out here. I think you can do like, we'll try that. So here I think you can say like, I'm going to store a phantom data thing, and I'm going to do phantom data, phantom data f. My language server just crashed, so I'm just going to close this and open it real quick. And then we're going to say impl drop for xkb pointer tf. And here we're going to say f is actually like an fn once that takes in a mute t, I guess. Associated type bindings are not allowed here. So this is be tf, and we put t and f here, where f is an fn once that takes in a mute t. Okay. And we will implement the drop function. And then can I just say like f self.inner? Is that like legal? Found type parameter f, not a function. Yeah, so maybe not. Can I like Rust store function as type? Can you store function as fields? Function as a struct field. That's not really what I want. Like Rust unique pointer style function as type or something. Yeah, maybe this is not gonna work out. So we'll just store the function. That's okay. We're willing to take the hit on a little bit of extra memory usage. So we'll say free function is a so we could do it 2 ways. We could either like we could make a generic pointer type, or we could make a macro that creates a struct that will embed the drop function, which I kind of like better. So we'll say what? Macro rules. And we'll call this like xkb pointer wrapper or something. And I can never remember if the exclamation mark point goes at the end of here. I think it does. And what's this guy going to take in? He's going to take in the name, which is a identifier. I think it's $name : ID. I always forget the syntax here, and I'm sure we'll figure it out in a second. And then we're going to take in the inner type, which is going to be a type. And we're going to take a drop function, which I think is going to be an expression, if I remember correctly. And he's going to say struct name, whose inner is going to be mute inner. And we're going to create our drop function. Our drop function for name. And the drop function is going to say drop function self inner. And then I think that will let us do something like xkb pointer wrapper. And what we're trying to wrap originally, we were trying to wrap the bindings. We're going to call this context. And we were trying to wrap bindings xkb context. And the drop function was going to be whatever the free function is for xkb context. So, somewhere in here, they should have xkb context unref, probably, and possibly free it, yeah. So here we'll say xkb context unref. And does that produce, like, valid code? So here he's mad that this isn't ident. But otherwise, that looks like it's working the way I want it, which is pretty sick. Pretty sick. So operation is unsafe and requires an unsafe function. So we'll just say unsafe here. And otherwise, that's working pretty well. Okay. So I guess now we need a way to like use this guy. So here he's going to be a context. And I guess maybe it's kind of nicer, instead of making him use like inner, we can say mute inner like this as like a tuple struct or whatever it's called, which allows me to make it like this. I can just say context like this. And I guess we throw this in an unsafe. And this guy needs to pull in bindings. Which he claims doesn't exist in there, which is kind of interesting. So can I look at the bindings and see what's in there? xkb context. So the naming convention is slightly different. It's xkb context flags. What a funny enum name. xkb context flags, xkb context no flags. Okay. So now we've created our context. And if this is like invalid, then we will fail. So I guess maybe it makes sense for us to auto-generate these like new functions. So we'll say function new takes in the pointer. So this guy takes in this, and he returns an option, we'll call it. And he takes in he returns an option of name. And so all he's going to do is he's just essentially going to null check this guy. So he's going to say, if inner is null, return none. Otherwise, return name. Return name with inner. And we wrap this with a sum because this succeeded, which lets us make a context new findings. Yeah. And then we can say our first error type will be fail context creation failed. And we can say I guess we'll probably make like a lot of stuff in here unsafe, because just fuck it. And this guy's gonna say okay, or xkb creation error, context creation failed, and return. There we go. Cool. Okay, so does that still build? Sure does. We'll format it real quick. And that was a long road to get here. So hopefully the next ones are quicker. So what's the next thing that we did in our test file? We mallocked some memory to read in the key map string. So let's do the equivalent of that guy. So we're going to say, I guess we'll do that first, because that's like the thing that's most likely to fail. It doesn't matter. So we'll say let f is equal to... What am I supposed to do? I think there's buff reader in Rust. Can I mmap it? Is mmapping too overkill? I don't really want to deal with that, so we'll just read into a buffer. Fuck it. So buff read in Rust. Let's take a quick peek skis there. So we make an IO buff reader. And we also need like a fs file. And so we'll say let f is equal to file open xkb mapping path. And we also have to convert this into a buff reader. So we'll say buff reader new file open. And if the file open fails, we have to map the error into a xkb creation error open mappings, which doesn't exist yet, but we'll handle that in a second. So this is going to be open mappings, and he's going to have inside him whatever a file open error can be, which is a IO result. Or, sorry, IO error, I guess. So it's going to be error as IO error. Noise. So this guy's going to have an IO error inside him. And then it looks like that's compiling. And so let's cargo check. Cargo format, and we're back. So now we have our file, and we have to read him. So we're going to say let file or mapping string is equal to f.read to end, which is from IO read. Do I need buff read as well? I can't remember if this guy has like a better API. So he has nothing here that's just like read everything. So read to end is fine. And we'll say, I guess this is not the right thing. We say let mapping stir is vec new. Read to end. I think we pass in the buffer to read to. And I'm assuming that it will automatically expand this buffer. So I think that we can just say mapping string here. F needs to be mutable. And this has a result. So here we'll say, if this fails, we have to map this into a xkb creation error read mappings. And here we just do the same thing where we say open mappings also is a read mappings equivalent. Cool. And then we try to create the mapping. So we need to wrap the mappings thing as well. So this we'll call a key map. And he wraps xkbcommon. And his free function, I assume, is like xkbcommon onRef, I assume, but we should double check that. So presumably here he has ref and unref, release a reference on a key map and possibly free it. So we're going to assume that this is how you're supposed to free these guys. Key amp is the wrong word. This would be key map. And so now we just say, do the same thing. So we say let key map is equal to key map new bindings xkb key map new from, what's the difference between from buffer and from string? New from buffer. What's this guy do? But takes a length argument so that the input string doesn't have to be 0 terminated. Sick. All right, we'll do that. So his context is the context. What we should do is we should automatically deref into the pointer type. So we'll say impl deref for name. Target is the inner. And is that what I want? Yeah, sure, fuck it. And then it's like function deref takes in self and returns self target. And I think he returns him as a reference. So then here we like return and self.0 or something. Maybe and star self.0. I'm not really sure. We'll see. So here we pass in the context and the buffer. So actually, I guess I don't want this to be deref. I want like a function to be as pointer. Yeah, I like that better. And he returns mute inner. And he just returns self.0. I like that better. So now we say context as pointer. And what are the other arguments of this guy? Buffer. So this is the mapping string. So we'll say as pointer. The length is the mapping strlen. Format is xkb key map format text v1. And we want the flags to be xkb key map compile no flags. All right. So he's got some complaints. So specifically, I need to cast that as pointer from a U8 to an I8, which is fine. That's fine by me. And now, what's he bitching about? Arguments is function incorrect. Argument of type mute xkb context is missing. Oh, because I put the cast on the wrong guy. So now he's saying that I forgot to put bindings in front of these fucking long-ass enum names. Now it compiles with kernel format and foreground, and look at this shit show, but that's okay. Okay, and then we have to say okay or xkb creation error, and we'll say key map creation failed, and here we'll call this key map. Cool. So now our struct will also take in the key map here. And the last thing that we had in our little test program was the state. And I think that was it. So we'll just do the same thing here. So this is state. We also have to say, you know what? You can be unused if you want to be. Shut the fuck up, compiler. I don't care. Okay. So now we say let state is equal to state new. We already fucked this up. This should be xkb state here, and we can assume that we're going to follow the same pattern and have state unref here. Cool. And so then we say findings xkb state new key map as pointer. Nice. And then we say state is state. And I think we're ready. So now we can return okay. I guess we need to also check here that this succeeded. So say okay or xkb creation error. State creation failed. Which it shouldn't, but it might. And then we can just say, okay, xkb. And he takes in the context, the key map, and the state. Easy fucking peasy. So if I run this now, I think that it should just not fail, but still work. Nice. And if I pass in any other file, like if I just pass in like a bad argument, I thought that this would crash, but it doesn't, which is a problem. MetaMe raided with a party of 17 viewers. Thanks for the raid, man. Appreciate it. For those of you who are just joining from the raid, what we're working on is we're working on this like key press logger on the right for my GNU plus Linux system, as they call it. Some people call it. And what we're kind of working on today is my keyboard has this like swap control and caps lock thing going, and the mechanism that we're reading the keys with is we're like reading the key presses directly from the Linux kernel using these like event pointers or like these event file descriptors essentially. And these guys don't have access to this layout, so basically we're trying to like inject the layout information by using this library libxkbcommon, and we're kind of working on like integrating that with our like Rust application essentially. Pretty fun stuff. Thank goodness you put GNU in there. RMS is happy. Yeah. he's a stickler for sure. I kind of wish he wasn't happy, but it is what it is. Dude, every time I think about that guy, I know it's like slander, but I just can't help but think about that video where he eats his toe jam. It's just like, yeah, that's kind of like the guy. It fits the character. He's a character, but he's done a lot for open source, so you can't shit on him too hard. Okay. Let's see. So I've got my like context created, and so now it's like, what do I actually want to do with this guy? Well, presumably we're going to get key codes from our lib event thing, or like our event device, and we're gonna pass them in here, and presumably we're gonna want to get something out. So maybe we'll just call like push code and we'll use this code to update like our state. So like say somebody presses shift, we'll update the internal xkb state with that. And so we'll take in like our key code 16 push key code, and maybe what we get back is like an option string. Maybe we'll have to figure that out. And presumably this will be like, if I press A, it'll come back with like a lowercase or capital case A. Maybe this will be like an enum later. We'll maybe figure out what that'll look like as we try to use it, and as we we'll discover what the API should be. Wait, you're not supposed to eat toe cheese? Well, look, like if you do it, I'm not gonna stop you and say you shouldn't. I'm just gonna say that everybody in the world who looks at you will be like, that's fucking gross, right? That's kind of And so, like, you know, maybe you shouldn't do it on camera while giving a lecture is really the bigger problem. He's like Tom Bombadil without the powers and hygiene. So, like, what does Tom Bombadil have other than powers and presumably hygiene? You're just kind of saying he's just like a guy, right? Okay, sorry. Push keycode. So in our main loop, we're gonna have somewhere, we have like this thread who's reading from this file. And when he gets a key, let's try just like kind of shoving him into XKB and we'll see what happens. So, I guess maybe we have like one thread that's reading from the file and forwarding to the GUI. Have a good stream, bye. Hey, yeah, thanks. Catch you later. And then on the app side, which is like who's handling GUI state, he's going to like convert those key presses for now. I guess we'll handle this over here. We might decide that we want him to live on the like reader thread side. But for now, let's shove him in here. So here he's going to have an XKB inside him. And here I guess we'll create the XKB, which we've done. So we just have to pass him in here for XKB as an XKB. He gets like an XKB in here. And now when we call this guy, we have to use XKB here. I think. He's bitching about something. It's because I just put the order of these things in like... No, I don't see what the problem here is. Oh, probably I didn't expect failed to create XKB. That's what we're looking for. He's complaining that he doesn't have debug implemented, so we'll just huck a debug on this guy so that they can print him. What I really should do here is I should like create like proper error strings for these guys and implement the error type. But I don't feel like doing that work. But like, you know, these are like good enough for me to understand, but if I were to make like a real application, I would use like this error and say like, failed to create XKB context. And then you'd have like error chaining and stuff, but I just don't want to deal with that right now. So we'll just derive debug and crash the program. So let's go back to this XKB implementation and just say this is unimplemented for now. Cargo run. And hopefully now I actually see the program crash when... Nice. So failed to... Nice. Yeah, this is exactly what I want. So this says failed to create XKB. You tried to open the mappings, but the file was not found. Sick. And if I pass in test.xkb, the program launch succeeds. Very, very cool. Okay. So here we have to push our key codes, and let's look at like where we're going to push them from. So here, when we process an input event, we create like a key history item. And I guess here we'll convert the code into what we get back from this like XKB guy. Because the state of, how do I say this? The state, like what key character we get out of this will be associated with like the state of our key presses at the current time. So storing them in history as the like process thing makes sense. So I guess here we will take our event. How do I say this? We will take our event and we have the key code associated with it. And we will self xkb push key code. And I guess we also have to check what direction is being pushed, right? So we'll throw in an is key down of the event. And then I guess we'll get back what it is. So instead of doing our like manual conversion of a code to a key press, I guess we're gonna like do that with XKB, because right now we were doing a conversion from like a number basically into a like am I control or not. But this is the part that's buggy, right? This is the part where when we check control, we actually want caps lock to map to control here. So I guess who's using this like keypress guy? I guess it makes sense for the XKB stuff to own like the type of the button push. Yeah, so let's maybe move this guy over here, this key press structure. And I guess what we're kind of saying is we're going to return this from this push code guy. And maybe in here, he's going to store a static string instead of a key code. Maybe. We'll find out. We'll find out as we go what makes sense. I guess we're also doing this like modifiers shit, so we'll have to figure out what we want to do with that later. Because I think that the modifiers are probably going to be tracked by XKB as well. Let's take a look at this. So probably in like the XKB state, one of the many things in here, I assume, is which modifiers are pressed down. Serialize mods, and he comes back with a mod mask, and oh nice, so I can like say, hey, which modifiers are pressed down right now or latched? What the fuck is the difference between depressed and latched? Oh, so I guess if I press caps lock, that will latch the shift modifier, I guess. Let's see like what type of like outputs they have here. Mod mask. Type def uint32 mod mask. But like what are the, oh god damn it. So XKB mod invalid. How do I like convert these back into, oh, here we go. Mod. No, this isn't it. Somewhere in here, I'm assuming that there's like definitions for the many different modifiers that could be pressed down, right? Where, so these are their names, but how do I get from like mod mask to mod name? Is there like functions that are associated with these guys? Maybe I'll just jump into my like generated bindings and see if I can find anything related to mod in here. Mod mask. Get mods for level. Update mask. Serialize mods. This turns back into a mod mask. But like, what is it? Come on, man. Maybe I'm sure that there must be like, there must be defines for these somewhere at least. No? That's very odd. Very odd. XKB mod mask T. I just want to know like, I just want to know how I'm supposed to like map these back into which buttons are actually pressed. Mod mask. Interesting. None of these. Oh, get consumed mods. No. I'm looking for like a function that takes in the mod mask and like tells me something else. Fuck. I guess if we look at the implementation of the state, we can look at like when somebody pushes down, like when they get a control press, they must update the mask. XKB keymap num mods. Okay, so they cast like, oh, this is like a mask for the mods, and they say the base mods is equal to this, but what do they like update? Get effective. Keymap. But somewhere like a key code must convert into a modifier press. Which I think we saw in our little test program. We saw that if we called xkb state update key, this updated if it was like a shift press. So I guess somewhere in here, they're going to set the mods. Yeah. So they have state, mods, bit. This is crazy. So set mods equals to 0. If we... What the fuck? Oh, I see. XKB filter apply all probably sets that state mods flag, I guess. Get action filter. So this get action does some like layout shit. Oh, this is so complicated. Like Avril Lavigne said, it's always something complicated. Fuck. Okay. I guess it would be like, how do I xkb mod mask check shift? Like somebody must have asked this. Somebody's asked this before. This guy's working with GLFW. That's not what I want. Too high level. XKB mod shift tab keysim. Oh, does this key sim that I get back tell me if shift is pressed? I guess it does, which maybe is what I'm looking for. So like somewhere in here, there's like a symbol that's returned from the state, I guess. We get one symbol. And one of maybe from here, we can extract what modifiers are pressed. Doesn't look like it. Capitalization transformation. Keysim transforms. If caps lock modifier is active and we are not consumed by the translation, a single keysim is performed to uppercase. If the control modifier is active and was not consumed by the translation product, the string produced is transformed to its matching ASCII control character. Keysims are not affected. Oh, God. Interpreting the control modifier. It is not consumed by the simple lookup process, blah, blah, blah. Okay, so I guess we just won't store state of modifiers in here. Like, we'll push them. We'll push shifts, because that's, like, relevant to us. Because I want to show uppercase or lowercase based off of shift displays. But I guess we'll just track modifier state externally, because fuck that noise. Essentially. Too complicated. Okay. So we have our XKB stuff. We want to push the event code, check if it's key down. And in our XKB stuff, we'll just say that here we update ourselves state. So we have like XKB update key. Was that what we did in our test code? We called XKB state update key. So this is in the bindings. We pass in the self state as pointer. And we pass in the key code plus the fdef offset. And is that it? Oh, and we set the direction. So we'll say match the direction here. So we'll say is down is a bool. And we'll say match is down. And if he is true, he goes to whatever the fuck that is. XKB key down. Is this the XKB key? It's supposed to be all uppercase. Bindings, XKB key down. None of these look right to me. Fuck. Fuck. Let's look for key down. Like, oh, was it a direction? Yeah, xkb key direction, xkb key down. Okay, we're remembering that. We're remembering xkb key direction. Bindings, xkb key direction, xkb key down. That's what I'm looking for. Solid. And he's probably not liking this is an unsafe call. And here evdev offset doesn't exist yet, so we'll say const evdev offset as a u16 is equal to 8. Oops, and this guy is where we're trying to do that. So we're just say bindings xkb key direction down. If this is false, we map it to up. Bing, bang, boom. And so then we'll just say let direction here is equal to this guy, and we'll pass in direction over here. This guy actually has to be a u32, and we'll say key code as u32 to plus evdev offset. Solid. Boom. Okay. And so then, I guess, does that guy return something? So we'll say keymax state, he has the update key, and he returns an xkb state component, which I don't really care about. And then when I say get one symbol, we will do, I guess we just pass it again with the symbol. So we'll see xkb state get one sim. And so we pass in the state and the key code again, but we don't need the direction this time. So this will account for shift and stuff. So we'll say let symbol is equal to this. This also has to be an unsafe block. That makes sense because we're interacting with C, and C is spooky and unsafe. Ooh. And then what did we do in our test program? We like converted this into a key name with xkb keysim get name. But what we want to do now is we want to, I guess we'll do that for now. Fuck it. So we'll say let name is xkb keysim. We'll say ret is equal to bindings xkb keysim get name. And we pass in the symbol, and then we have to create like a buffer to write into. So we'll say let buff is equal to something. I guess that means that we're not going to return a static reference to a string. We're actually going to return a string itself because we're going to allocate our buffer on the heap and then pass it back to the caller. So we'll say let buff is equal to a vector full of zeros. We'll make it 64 bytes long, and we will pass back the buff. We'll pass in the buff here, and the size is going to be buff len. And I guess we need to like convert this into a C string, because the C string is going to like take into account like the null terminator and stuff. So we'll say core FFI, or sorry, std FFI C string from vec with null. Solid. That exists. Love it. Love it. And for now, we'll just unwrap this. But I'll fix that later. And I guess I have to like convert this vector from like a bunch of u8s at this point to a bunch of i8s here. So I guess here we'll just say buff as mute pointer as mute i8. And then we put this as mutable over here. And we'll say let s equal to this. We'll say s dot to string lossy, I guess. And that's our return. He says to string is fine, so no. Weird. Oh, I just have to write to string at the end of this because there's like these like double string conversions. Gross. Right. Obviously a bunch of other stuff is gonna break because we just like removed some like important things here. Let's take out the like modifier handling for now. I guess we Yeah. Well, we'll see. Where's like all of the fucking bullshit? So, I guess we don't. No, I guess the key down is fine. This is still fine. So we push the key code. We get back the string. And otherwise, is this just like working okay? Cargo check. Oh, it does. Okay. So I guess we'll say let code is equal to, or like code string, and we'll print line on each of these guys the string. Sure. Let's just do that for now. I'm sure that this won't work correctly, but it's just going to give us like a little bit of like info as to like what this guy looks like. Okay, so we crashed. Sick. So we should actually check, I guess, when we push the string, we need to check if this failed. So here we can say if ret return none. And I guess if we say if ret is equals 0 is actually what we have to check here. And let's see if that guy does us any better. So that's still fucking crashing. So that's crashing at from vec with null error. So I'm guessing that that's this buffer here doesn't end up with the null that we want, which is interesting. Let's maybe print line ret. Let's see what we got. Like that. And maybe that will give us a clue as to why we're fucking crashing. So I press a button. He says ret is equal to 1. And so let's look at that actual API. So it's get name. Was that what it's called? Get name. Oi, oi, oi. I guess we can xkbcommon get name. So get the name of a keysim, blah, blah, blah. If the keysim is valid, returns -1. You may check if truncation is returned by comparing the return value with the length of the buffer. Okay, so maybe he doesn't null terminate? That seems possible. So we can actually say length here is this guy, and then we can say from vec. I guess we just don't have to make a C string then if it's not null terminated. I guess let's double check that. The documentation that I was reading there was like too fucking hard. So we have like the keysim somewhere. Why keysims? Here we go. And there's like a get name. Excluding the number of bytes in the name, excluding the null point. Null. Oh, so we're actually fucking this up already, the g minus 1. And the number of bytes in the name, excluding the null byte. Oh, never mind. So you may check if truncation was returned by comparing the return value with the length of the buffer. Okay, yeah, that makes sense. So why is this just not succeeding? He's saying from vec with null error kind interior null bytes 100 and then a bunch of zeros. Okay, so what's the fucking problem? 100 is like a valid ASCII character, right? I'm assuming. What's like ASCII table? Right, like 100. Is that just the button I pressed? Yeah, it's D. What did I press? Like, what the fuck is it bitching about? This is coming from push key code 121. Like, hello? What's the problem? There's a bytes with null. I must be high. Panic called on result unwrap. Error value from vec with null error. Well, I guess we'll just fucking look at the C string docs and see. From vec with null. And errors if a null byte is present and not the last element, or no null byte. Oh. That's so fucking stupid. Okay. Fine. So I guess we just say, in this case, buff.resize to len plus 1. Which is here. And I guess we need to specify a value to fill, so we'll throw 0 in here. Sure, and I think it's if len is less than 0, actually. And you convert an i32 as you... Sure, I think that should compile. No? He doesn't like that? Oh, because I have to put brackets around this. The cast has to apply to the entire addition. You can't have more than one null in a C string. Yeah, I got there eventually. I think that's fucking stupid, but it is what it is. Okay. So I am still getting caps lock when I press caps lock, which is kind of odd. Oh, no, I'm not. Sorry. I'm really looking at the wrong thing. So it's saying caps lock in my screen, but here I'm getting Control L when I press it, which is cool. I'm getting double logs on press and release, and if I hold shift, I'm getting capitals. What happens if I do like brace right, brace left, bracket left? So it does look like I'm getting something sane. Now the question is what do I want to do now? I need to use this map to convert this like caps lock press into a control press, which is going to be done by what? We're going to like ask it for like what fucking symbol was just pressed. And do I really just have to map the strings? I prefer to like map the values directly. But I don't know how to like get like match these reasonably. I'm assuming that they must have like definitions of symbols somewhere. xkbcommon symbols, xkbkey underscore. Aha! Yeah. So this is what I'm looking for, exactly. So then I can just compare to see if these are any of like the control or shift or whatever presses, and I will use those to track modifiers on my side. Okay. So I guess here we're not going to return a string anymore. We're going to return an option key press. And this guy is going to be control, shift, super, or string. Cool. So now this is going to be... We're going to say this is key press other, like this. Cool. And now we just have to handle the like other cases. So I guess here we're going to match symbol. And if it's bindings, xkb key control L, nice. Or bindings xkb key control R, then he is a key press control. Nice. This is coming together. Otherwise, he is this thing. This. So this turns into key press other this shit. Yeah, haha. So here we have to get the code here. And presumably somebody here is going to take in the code. No, I guess this is nothing. This is nothing. Okay. And then here we say let ret is equal to this guy. And we return ret. And maybe he needs to be wrapped in something. And now we're moving. So I guess we also have to check if this is a key down event or not. And I think we're going to change this keysim get name to get UTF-8. Because I think if I do that correctly, if I understand correctly, the UTF-8 will give me like brackets as like their brackets instead of their like fancy names or whatever. Fuck. So that was in like xkb. Oh, I lost it. Keysims to UTF-8. Keysim to UTF-8. Yeah. Okay, so xkb. So here we're going to have xkb keysim to UTF-8, which I think was the name. xkb keysim to UTF-8, which takes in sim, buffer, and size. So here I'm passing in sim, buffer, and size. So that should just compile still. Give it a sec. Okay, so if I press buttons, we crash, which is very sick. Because something here failed. I guess probably the return is not the same thing. Returns the number of bytes written to the buffer, including the terminating byte. If the keysim does... Okay, so the other one just wasn't including the terminating byte, and this one is, so that's really cool. I don't know why. Whatever. So now, hopefully, if I press D, I'm getting D, F, and if I press Shift, it probably crashes. That makes sense. And so now we just have to handle these, like, other cases. So I guess we have a few cases here. We have the cases where we succeeded in getting the UTF-8 string. But I guess we should fall back on, like, the number or something. So what happened when I pressed Shift? I got not null terminated, which is kind of interesting. So let's maybe print out length here and just see what that looks like. And so when I press Shift, he says, I got a length of 0. Ah, okay. So I'll just say if length is less than or equal to 0. And that will probably resolve the crashes when I press like an unsupported value. So I'm seeing Control, C. When I press caps lock, I get none. When I get Alt, I get none. Shift, I get none. Okay, sick. So now we just have to handle these like other cases. So I guess we'll try to get like the UTF-8 symbol, and if that fails, we'll just fall back on getting the name of the character. So here we say keysim get name. And here, then we say, this is mutable, len is equal to this, and then len, if len is less than 0, this is the length without the null terminator. Oh, sorry, this is length with the null terminator. So we do return none here, and then we add 1. This is without, so len plus equals 1. Okay, and then hopefully now when I press buttons that are not supported by like UTF-8 conversion, then I get like their alternate name instead. So here if I press like Shift, I'm getting Shift L, caps lock, Alt L, sick. Sick, sick, sick. Okay, so now we just have to throw in some extra of these guys. So we'll just say Shift here. Shift, because these are modifier keys. We want to handle them specially. So this Alt, Control goes to Alt, and this is key press Alt, and the last one would be like the meta key. So I don't know if they call it like meta. Yeah, they do. Nice. Nice. Meta R, and this is super, is what we're calling it. Hello, I'd like to switch to Linux, but don't know where to start. Do you have any tips or types of Linux that I should start with? I would say, I don't know if like the advice has changed over time, but I would say it's pretty easy to install Ubuntu, right? You just like get the USB stick, you shove it in there, you burn the ISO to the USB, and then it just gives you like a nice little install window or like an install wizard. That's where I would start. I would probably start also with installing it in a virtual machine before I pull the trigger on like a full desktop. But that's kind of up to you. Or you can stay on Windows. You know, that's also a valid alternative. He started with his concept was I would like to switch to Linux. So I think saying don't is like probably not very helpful. But yeah, I would pick Ubuntu. This guy's saying if it's your first Linux, don't choose LFS or Gentoo. Everything else is fine. I would kind of put on the extra caveat that like stuff like Fedora is like kind of a pain in the ass because you have these like extra permissions things to deal with, right? Like if you were going to start with Arch, that would also probably not be my go-to starting point. I would probably just say grab Ubuntu and start playing around. But yeah, it also like kind of depends on like what you're trying to accomplish by installing Linux. If you just think it's fun, go for it. The only thing to really be concerned about is if you like burn an ISO and hit the install button, you might wipe whatever's on your hard drive. So just be careful about like which disks you're doing stuff on, and I would personally start in VirtualBox or something just because that's an easier way to get going and it's like safer for your like real operating system. Yeah, okay. What the hell was I doing again? I was handling these modifier keys, and so I push this key code, I get back like information about my key press, and so I guess here I also want to filter out key ups, but I guess we can do that from the other side. So that's probably what I'll do. So here I'm going to get my key press somewhere. I'm going to process my input event, and I'm going to say that my let key press is equal to this guy, and we'll say that if we get nothing back, right? If this is a thing, we will return the thing, and if it's none, well, there's no more work to do here. We didn't actually get anything that we care about, so we'll just return early. Here we have these like checks for the type of key press, so I think that this is still reasonable. And we have an undeclared type key press, we just have to pull that guy in, so we'll just say use xkbcommon key press. And I think everything else just kind of lines up. I guess the only thing here that we want to do is our key history item used to store the key code, and now we'll just store the key. I guess we'll store the key string, which is a, I think it's just string. And this guy is going to say match. I guess here we have like everything else is going to be a key press other s, and he's going to propagate this up. So here we'll say key string is equal to this. We pull it out of that, and then we have the key s just is there. Boom. And presumably something else is not compiling because I'm trying to use code here. So we'll just say key s here. Boom. And instead of doing code to car here, we just pass in key s. Boom. Which is the wrong thing here. This is item key s. And I think other than that, it's probably all going to work. So if I cargo run, after fixing all those errors, are we just going to get what I want? Hey, that's kind of cool. That's kind of nice. Look at that. So now we're kind of handling, so when I hit Control-C, where my control is bound to caps lock, we're actually getting the right thing now, which is pretty fucking sick. If I hold Shift, I get the capital version, which is pretty sick. And if I hit caps lock, I get the capital versions as well. So that's pretty sick. I'm pretty happy with that. So we can delete these like code, these like string mappings that we had before. We don't need them anymore because XKB is handling for us. Yeah, and so I think that we integrated usage of mapping into the app. Okay, so that was kind of longer to get to that stage than I thought I would take. We're kind of at like the 2-hour mark now, which is pretty cool. That's kind of like about as long as I'm willing to stream for generally. I'll have to think about whether or not I want to do the other half of this project on stream, or if I'm just going to do it off stream tomorrow. But the other part is I need to like generate these mappings automatically. I need to like extract them somehow by basically just calling this other application and dumping it. I think that's probably short enough that it's not worth a stream. So I think I'm gonna call it there. If you liked what you saw, I stream most days around like 1 or 2 o'clock Pacific time for around 1 to 2 hours on Twitch. If you don't like watching live or you miss it or whatever, there's a YouTube link in the Twitch description. If you're watching on YouTube and you want to watch live and come by say hi, there should be a Twitch link in the YouTube description. Both descriptions should have a link to my GitHub, where this like code will eventually end up in its like more polished state. And yeah, people have been asking about a Discord. There's a Discord link in the Twitch description. I don't really know if it works properly, but it's there if you want to try it. And I'll try to like keep an eye on that Discord a little bit. Yeah, that's it for me. Thanks for watching, guys. Catch you on the next one. Bye.